This is section 9.2, reflections. And some vocabulary for this section is we have the word reflection, line of reflection, and also it's called opposite orientation. But before we get to talk about reflections and new material, we have some algebra review that we need to talk about, and specifically equations of lines, of horizontal and vertical lines. So let's look at a coordinate plane, and we'll look at a couple of examples of horizontal and vertical lines. So a horizontal line is any line that is parallel with the x-axis. So let's say if we put the line right here that crosses our y-intercept at 4, the slope is 0, and so we can say that the equation for this line is y is equal to 0x plus 4, which will just be y is equal to 4. And one more example of a horizontal line. Let's say this line here, let's say this line crosses down here at -3. Therefore, our equation on this line is just going to be y is equal to -3. So a horizontal line is always going to have the form y is equal to a constant, and that constant is the specific y-intercept that your line will cross. Now we can look at a vertical line. Say this vertical line is going to cross, let's say it crosses here at 5, and I'm looking at right here is where our x-intercept is 5. And so the equation there is going to be x is equal to 5. And another vertical line, let's say this one crosses at -1, our x-axis at -1, and so therefore on this line here, every value of x is going to be at -1. So we have x equals -1. And one more thing we should look at is the equation of our axes. So if I look at this horizontal line that crosses through, that is on the x-axis, notice that that is the equation of y is equal to 0. So the equation of the x-axis is y is equal to 0. That is the equation for the x-axis. And for the y-axis, notice on the y-axis, every value of x is equal to 0. So our equation of the y-axis, the equation is x is equal to 0 for the y-axis. So in our book, we will mostly be reflecting about vertical and horizontal lines, but we could actually reflect about any line. So our book also will sometimes reflect about the line y is equal to x, which would be the line that cuts right through here, or y is equal to -x, which would be this line. So here's our line y is equal to x. And here's our equation y is equal to -x. And we can remember that that's a slope of -1 and plus 0, which would mean that it would go through the origin. So now we can go back to our vocabulary and start talking about some of these terms. So the first term is reflection. So our reflection is a transformation where every point of a pre-image is mapped to another point, the image, which is the same distance from the line but on the other side of it. And this line that we're talking about is called the line of reflection. So if we look at this picture here, triangle BUG is our pre-image, here is our line of reflection, and over here is our image from our reflection. And if we notice, if we look at the distance from B to our line of reflection, B prime is the same distance away but on the other side of the line. Likewise, U to the line of reflection is the same distance as the line of reflection to U prime, and G to the line of reflection is the same as the distance from the line to G prime. So in this case here, triangle BUG gets reflected to B prime, U prime, G prime. And notice if we do BUG clockwise, over here we do counterclockwise to keep the corresponding angles matched. And that is what's called an opposite orientation. when the corresponding vertices of the pre-image and image read in opposite directions. So it's important to notice that whenever we have a reflection, we will have this opposite orientation occurring. So again, a reflection across a line M, and that line M is our line of reflection. So if we look at this picture, there's our line of reflection. Is a transformation with the following properties. If a point is on the line of reflection, then its image is also on the line of reflection. So point A is on the line of reflection, so A prime is also on the line of reflection. Secondly, if a point is not on the line of reflection, so B is not on the line of reflection, then B to B prime to its image is going to be perpendicular, because that's the shortest distance straight to the line of reflection, the same distance across from it. So those two lines, if we connect an image point with its pre-image, and the line of reflection will always be perpendicular. And furthermore, the distance from B to the line of reflection is equal to B prime to the line of reflection. So we can say that the pre-image B and its image B prime are equidistant from the line of reflection. And so for notation for reflections, we use a capital R to stand for rotation, and then down here in the subscript position, we write the equation of the line that we're reflecting about. So then we write the equation that we're reflecting about, and then last we write the pre-image, or the object that's going through the reflection. So an example of how we might write a reflection would be a reflection, and we're reflecting across the line y is equal to 3, and for this example we're reflecting triangle ABC. Alright, so let's look at an example where we're reflecting a point across a line. So we're just going to do one point. We're going to do point P, has the coordinates of 3, 4, and we're going to reflect the point through this, so this reflection, so that's a reflection about or across the line y is equal to 1 and point P. So we're going to be given choices in this example. We have A, B, C, or D. So if we're looking at this example, we can go ahead and graph point P and the line of reflection y is equal to 1. So here's our graph. Here's our point P, and here's our equation y is equal to 1. So what we're going to do is we're going to take our point and move it 90 degrees to our line of reflection, and then we continue the same distance away. So point P is 1, 2, 3 spaces above our line of reflection, so that means P prime, its image, has to be 1, 2, 3 spaces below. So since P is 3 units above the line y is equal to 1, P prime must be 3 units below y is equal to 1. And so if we look at those coordinates now we can just read those coordinates, and those coordinates are going to be at 3, negative 2. So the correct answer would be C. So here we're talking about some properties of reflections. So RM just means a reflection about some line M. And so a couple of properties is reflections preserve distance. And what that means is that, say, a segment AB in your pre-image is going to be equal to A prime B prime in your image. That's another way to say that reflections are rigid transformations, that lengths of objects and the images remain the same. Furthermore, for rigid transformations, angles are preserved. So angle B here is going to be equal to or congruent to angle B prime. And the last property that we talk about with reflections is that the reflection of point A of any point has its image, and then if you did a reflection of the image, you're going to get back to your pre-image. And so they are reflections of each other. And again, all of these properties really are the properties that maintain that reflections are what we call rigid motions. Let's look at another example where we are going to be graphing a triangle ABC. So here we are going to graph points A, B, and C to make our triangle ABC, and we're going to reflect it about the y-axis. So step one is to go ahead and graph our pre-image triangle ABC. So here's our triangle ABC, and we graph our line of reflection, which is the y-axis, and that equation of the y-axis again is x equals 0. Okay, then step 2 is to find our image points. So find A prime, B prime, and C prime. And remembering that each of these points is going to be the same distance away from our line of reflection, but on the opposite side of it. And we notice that B, since B is on our line of reflection, then our B prime will also be on our line of reflection. Then A prime, if we go to find A prime, we look at point A, which is 1, 2, 3 away from our line of reflection, so we continue 3 the other direction. C is on our right side of our line, so we count 1, 2, 3, 4. 1, 2, 3, 4. So C prime is going to be over here on the left side. So now we're on to step 3, where we can draw our image triangle A prime, B prime, C prime. And triangle A prime, B prime, C prime will be here. So in this case, these two figures do overlap. And notice that our image points, A prime is on, and A are on the opposite sides of the line of reflection, and C and C prime are on opposite sides of the line of reflection. And point B prime is actually on the line of reflection because B is on the line of reflection. So in this example, we have 4 triangles, and each of these triangles is going to be a reflection of another one. And we have 2 lines. We have line K and line M. And so our job is to figure out which 2 images or which 2 figures are a pre-image and image, and about which line of reflection. So the first question is saying, how can we describe triangle 2 by using the reflection rule? So here's triangle 2. Now the question is triangle 2 a reflection of 1, 3, or 4, and about which line? So first we can say that triangle 2 is the image of a reflection, so we need to find the pre-image. So first of all, we could say that the pre-image cannot be triangle 3, because 2 and 3 both have the same orientation. If we remember, with reflections, we always have to have opposite orientations. Triangle 2 and 3 would actually look like they would be some sort of a translation. Notice they have the same orientation. But 2 and 1 and 2 and 4 don't have the same orientation exactly. So next we're going to check triangles 1 and 4, and we can do that by drawing segments connecting the corresponding vertices between triangle 2 and the corresponding vertices of 4 and 1. So notice when we connect the corresponding vertices of 1 and 2, this line here is not going to be perpendicular to either of our lines of reflection, so that kind of rules out triangle 1 as being the pre-image. If we look at triangle 4 and we connect the corresponding parts, notice how we end up with right angles, perpendicular with all of these. So therefore, line K is going to be perpendicular. Line K is perpendicular to all of these lines connecting image and pre-image. And so triangle 2 is going to equal to the reflection about line K of triangle 4. So then the next question is, how can we use the reflection rule to describe triangle 1? So triangle 1, How can we find which triangle is going to be its reflection? And this exercise will probably be left for the online question. All right, so next we're going to look for patterns in order to determine what our reflection is. And so if we look at our pre-image points, we have A, B, C, and that's 4, 5, 4, 5, 7, 1, and 9, 6. So those are our pre-image points. And now let's look at our image values. Our image values are 6, 5 for A prime, 6, 5, 3, 1, and 1, 6. So then our job is to determine the reflection that's going to map ABC onto A prime, B prime, C prime by looking at the patterns that we have here. So to begin with, we can notice that for our pre-image, our y-coordinates, and our image y-coordinates, notice they don't change. 5, 1, 6, 5, 1, 6. So our y value hasn't changed, but our x values have changed. Therefore, we know it's got to be an x equal. An x has got to change. And when we have an x equal a constant, that is a vertical line. And so we will be looking for the vertical line that is our line of reflection. So we can see it in the picture here, but if we didn't have that, how would we find it? We can notice that this line is directly between our C prime and our C. This line is also directly between B prime and B and between A and A prime. So this line of reflection is directly in the middle or the midpoint of these values. And so what we need to do is find the value that's directly in the middle, x equal a constant. Looking at the picture, we can tell that it's going to be at 5. If we didn't have the picture to refer to, we can look at our coordinates. So let's just look at C. X value is 9. Our C prime, x value is 1. The value that's directly in the middle of those is going to be your average. So if we take 9 plus 1 is 10, divided by 2, we get 5, which is x equals 5. And notice that works with all of our points. 7 plus 3. 7 plus 3 is 10, divided by 2 is 5. X equals 5. And also even 4 plus 6 is 10, divided by 2, we get x is equal to 5 again. So then to write this in our book notation, we would say that this is a reflection about the line x is equal to 5 and its triangle ABC. So in this example, we have triangle AEY being reflected to A prime, E prime, Y prime. And what we need to do is find this line of reflection. So we can do that by studying our pre-image values and our image coordinates. And notice in this case, the x's remain the same. So our x's are not changing, but our y's are changing. So our line of reflection is going to be a y equal, which is going to be a horizontal line. So exactly what is the equation of that horizontal line? Well, let's look at our y values. 0, negative 2, if we're looking at point A. So here A is at a height of 0. It's on the x-axis. Here our A is at a negative 2. And so our line of reflection should be right in the middle of those. So what number is right between 0 and negative 2? Well, that should be negative 1. We can also check our other coordinates, 4 and negative 6. And again, we could do the average. 4 plus negative 6. 4 plus negative 6 is negative 2. Divided by 2, we get negative 1. Y equals negative 1. Even here, 1 plus a negative 3 is negative 2. Divided by 2, we get negative 1. So in either case, whichever way we do it, we find that y is equal to negative 1. So that's our line of reflection. So we could write our rule as follows. And our reflection is going to be about the line y is equal to 1, and we're reflecting triangle AEY. AEY, our pre-image. Next, we're going to look at what happens when we reflect across diagonal lines. So these are lines that are not horizontal or vertical, but are at some sort of a diagonal. And the first diagonal line we're going to look at is the equation y is equal to x. This would be our line of reflection. If we think about this in slope-intercept form, that's y is equal to 1x plus 0. These are essentially the same equations, and so our slope is a positive 1, and our y-intercept is 0, or through the origin. So here's our equation, y is equal to x, and our figure, our pre-image, A, B, C, D, is going to be reflected in this line, or across this line, so it should end up to be over here. So remember, to find our images, we're going to go straight 90 degrees through our line of reflection and the same distance away. So B prime would be here, C prime, 90 degrees, would be in here somewhere, A prime, so forth, and then, the D prime. So then our image would be right over here. And let's go ahead and look at the coordinates of our pre-image and our image. If we study the pre-image versus the image, we can quickly see that between the pre-image and the image, that the x and y have switched places. In other words, the y is equal to x, and the x value is equal to the y value. Or we could say that every pre-image point, xy, is mapped to yx. And this will be true whenever we are reflecting about the y is equal to x line. Whenever we're reflecting about this, we simply switch the x and y coordinates. Now let's look at the reflection about the line y is equal to negative x. So here's our line y is equal to negative x. Notice it's got a negative 1 slope. So we are looking at the reflection about the line y is equal to negative x and our figure APTR. And that reflection will yield this image, A prime, R prime, T prime, P prime. And let's go ahead and put down the coordinates so we can study those. And when we study these coordinates, not only do the x and y switch places, but the sign is also changed. So 5, 1 becomes negative 5, negative 1. And 4, 3 becomes negative 3, negative 4. In other words, the x value becomes the opposite of y and vice versa. So the xy becomes negative y, negative x. So the xy have switched places and they've changed signs. And that will always be the case when we reflect about the line y is equal to negative x.